self-organization, you usually have a lot of crisis events, and you have emerging phenomena. And particularly if you try to build a scalable system, it's very important actually to take that into account. So that's why when you try to use a data science approach, for instance, for modeling the flock of the birds, then you will actually fail, because it will not work for many aspects. And another aspect which is important, when you want to model the crises, actually no machine learning technique will allow you to model the crisis as well. So, because if you haven't seen them in advance, or if you haven't seen them a lot of times, so you can teach your system to recognize these events, so then it just doesn't work. So it will be some anomaly, you could recognize that there was an anomaly, but you cannot predict it. So it's important actually to make a step back, and physicists did it a lot of times. So, and they model this kind of system, this kind of complex system, that's the general name for these things, from the bottom-up approach. So they start from the very beginning, say, okay, it's a bird's flock, okay, let's take one bird, and then say what could be the minimal viable set of rules for this particular single bird, which will actually model this big flock, and which will allow this modeled simulation to reproduce what happens in reality. So I will do the same thing for, let's say, business ecosystems, and particular for blockchain ecosystems. And this is very important when we actually speak about real business ecosystems. So one thing about birds, they are flying nicely, and we like to watch them. But another thing when we have, let's say, an economy, and from time to time we have crises. And every time there is a crisis, every time actually those guys who try to model it with some linear model, they actually fail. Even when they actually had some similar kind of crises in the past. Usually these are events which are very hard to model. But if you take this agent-based modeling, when you start from the very simple agents and then try to model a big scalable system from these agents, then actually you can predict the crises. And one of the things in my research as a researcher I did when I've been in academia was research on modeling, for instance, disease propagations, when you don't have a continuous transition, but actually a rapid jump in the propagation of disease. And then you can revert these transitions from outbreak to, let's say, controllable disease in the population. So in the economy, that's of course is reflected in the crises. So a quick recap about blockchain. I will not go into details because we are data scientists and machine learners and researchers, so we don't really care about all these engineering techniques of how to engineer the blockchain. But the idea is that you have this distributed ledger database, which first of all is immutable because you have a specific mechanics of how you add data in this database. This data actually represents transactions in your ecosystem or some smart contracts. And you have a specific mechanism of these hash functions of how you actually build a next block dependent on the previous blocks and all the data inside the block. So then actually you have this distributed database. In the simplest example, every node on your blockchain actually has a copy of it, and it's immutable, so you cannot really change the order of the elements in the database. And the very nice property of this thing is that you have so-called consensus mechanisms which allow you to control of how you add new data into this system. So you have not some external party which validates these transactions, but you have an ecosystem itself which actually validates transactions in the system. So these are the main properties why it's interesting. But here, if you look on this, it's very transparent, it's very nice, and immediately if you try to model some business process with blockchain, not model, but take some business process and put it on blockchain, you think like, oh, it works so efficiently. It's very scalable, so I can include more and more participants into the ecosystem, and it will grow, and I will confuse the world. So and here's the question: if it's actually scalable, so how we can assess that? And let me just outline how I understand scalable and not scalable. So you can of course take some business process and put it on blockchain, and that there will be few participants in this business process. They will have some smart contracts which moderate the transactions between participants. But there will be a finite number of them, and you don't plan to grow them. So then I say that this process is not scalable, so it's fixed. And we, in principle, can model that and predict everything, and that will be fine. But the scalable one, it's something that we have, for instance, for some platforms. So you can build a platform, for instance, for traders, which will use blockchain to buy or sell some stocks, or use, let's say, some goods or commodities. And then, actually, the number of participants in your system can grow, and your system will kind of play a role of moderating these transactions in between participants. But it will not fix their numbers, so you actually expect and you want them to grow. And in this particular case, it's very important to understand that it's not enough to just fix the elementary smart contracts rules and elementary rules of business processes. It's actually also important to think about how all this ecosystem will work in general. And we actually had a client, so how I came to that. So I am a physicist, I'm working with this agent-based modeling for a long time already. And I saw that it's very nice research problems. So you have all these births, you have disease propagations and so on. I knew that the people use it in the economy. But then there came this client and saying that they have a blockchain ecosystem and they want to grow. And they are very afraid of actually this ecosystem to break down or to explode, because every new participant actually pays a lot of money to jump in. And that could cost a lot of losses for their clients. So they wanted to explore how possibly we can actually assess this. And we used this technique. So let's also recap how usually there are a lot of startups which use blockchain and they go to market. And how usually this process goes, so they have some idea, and they build some prototype, then they write a white paper, and this white paper speaks about what kind of rules they have inside their blockchain or smart contracts, how they build smart contracts, what is the structure of the smart contract, and then they go to market. And then they either fail, most likely, or they actually bring a lot of money. And the thing is that it's okay. So sometimes startups just fail, sometimes they bring a lot of money. But the thing is that if you try to go to some problems where actually failure costs a lot of money, let's say you want to put some processes within the EU, let's say processes which take a lot of paperwork, you want to put it on blockchain to reduce this paperwork. And it might be a very nice idea, it will save a lot of resources, costs on this paperwork, but then it can grow very easily because EU is a big market. And then suddenly it can actually, at some scale, it can actually fail. So then it will be very, very expensive to have this ecosystem really fail. So you will have some stakeholders asking you how scalable is your blockchain, how you can actually prove that your ecosystem which you are building on top of the blockchain will actually survive at the scale. So let's speak about the problems. What type of the problems we have and why it's so hard to answer. So first thing is that we have little to no data. So it's a data science conference, everyone thinks that there is huge amount of data and you can just use the data and build some predictor on that data and predict if your system will actually grow or not. But here, usually you want to innovate, you want to put some new process you want to build some new process, and you have no data. So that's one thing. Another thing is that if you have some crisis events, usually linear predictors, they just don't do that. So they can predict only continuous, let's say, continuous transitions. Also, if you speak about these complex systems, for instance, flock of birds that I was saying about, the interesting thing is that these systems are highly nonlinear, and there are very strong finite size effects. So, like if you have 10 participants, like you say you created your ecosystem and you tested it on focus group on 10 participants, it works perfectly. But then you have hundreds of them and it works completely different. Then you have thousands of them and it works again completely different. So it's very important actually to know how the system works at different scales. So at some very large amount of participants, it actually will go to some scale to some regime, but still for these small amounts like 10, 100, 1,000, 10,000, you will have these strong finite size effects. And particularly in these ecosystems, you also have this emergent behavior, so at some point, these transactions that you actually included in your system, they will lead to some much more like coarse-grained effects on the scale. So let's go to agent-based modeling. So where does it come from? So I'm personally a physicist. I actually worked in the Institute for the Physics of Complex Systems in Germany before, and then in physics department at Weizmann Institute of Science. So this picture actually is from Weizmann Institute. So there was a group studying the behavior of ants. And the idea is that these creatures, so we think that they are very smart, but apparently they are not. So they are very smart when they behave as a group. And when you have individuals of ants, they actually have very, very simple rules of how they interact. And this group actually, they built a model which models how these ants, for instance, take some object and move it to the nest. And they took individual, they modeled it from this bottom-up approach. So they took individuals ants, they gave them some simple rules of how they behave, and then apparently when they put a lot of such agents in the simulations, apparently they start to self-organize and they move the object to the nest. And that's reproduced the experimental results that they collected. So this is kind of this detour from economics. So now, if you look on the literature, there are quite a lot of different papers, there are quite a lot of books already written, but for a while, I think till like middle of 2000, it was more like a research approach. So a lot of physicists worked on it, so physicists then transferred that to so-called econophysics, physics which studies economy, or physics which studies society, social physics, biophysics, and so on. And somewhere in the middle of 2000, when the power or computer power was enough to model economy, people started to use it, for instance, in the stock market, and to model the economy of different countries. For instance, in EU, people use it to model the economy of EU. And so there are quite a lot of literature already based, so you can take a look and learn how to build these models. And so here is a particular example of how it works, for instance, to apply to economy of supply chain. So you have a lot of customers on the lower layer, and these customers interact with retailers. And these retailers are, let's say, some shops around us. And these retailers, on the next step, interact with wholesalers. Those interact with distributors. There is a number of distributors, and those interact with factories and suppliers. So all these guys, you can model in the simulation. You could say that these customers have very simple rules, and they from time to time demand some product from the retailer. Retailer can provide this product to customer, but also can demand this product from wholesaler, and so on and so on. You go one layer, step by step, to the next layer. And the thing is that if you have the system large enough, it actually becomes very complex. So you have it like correlations and interactions of next and next order, and so it's very hard to. It becomes more and more nonlinear. And generally speaking, what you can study here in the simulation, it could be, for instance, the flow of goods and the flow of money. And then you can study the liquidity of goods and finances. And if there are some squeezes of this liquidity, then there is a problem of, for instance, for customers to get some goods, or for factory to get back their money when they provide some goods to distributors and further on in the chain. So this figure actually is taken from one of those books that I just showed. So now, why it works for blockchain? So apparently this is the blockchain and agent-based modeling, they like fit together very nicely. Then the reason for that is that on blockchain you actually have very nicely defined agents. So every node on the blockchain is basically your agent, but you can of course make them bigger and like coarse grain them, but generally they are very simple. Then you have very nicely defined discrete steps. So because you cannot add like multiple transactions on your ladder, you actually add them one by one. So you have kind of stochastic, not stochastic, but discrete time steps. You also have, once you build your smart contracts, you actually have very well-defined interactions between parties, between agents. And finally, what I said already is that historical data usually is scarce. So this is more or less the only approach you can use. So how to implement it? So don't show any code or anything like that, but let me just on the high level outline how we do that. So on the high level, this agent-based modeling, it merges together two concepts. One concept is discrete event simulation, and another concept is basically object-oriented programming. So in discrete event simulation, that's what I said, that you discretize your time in the very well defined steps. Let's say you add one transaction onto your ladder, or you create one more smart contract. And you have agents which could be represented once you have some object-oriented language. Then you can easily represent agents like some object. And then we have a factory class which actually creates which is an object which creates another object. So you can create multiple number of those objects. And agents will have some attributes, and it will have some actions which actually are methods of this agent. So once you have these two concepts, you can actually build it either on your own. So we do it in Python, but also in the research community there are some frameworks for that, but I don't recommend to use them because usually they are a little bit like crafted for very basic, I would say, educational problems, but not really for real life. For real life, you could just take a Python and build this on your own in Python. And what it gives us. So let's say you have some ecosystem based on blockchain, and you start with having some design of it and some rules defined. So then you try and build your model. So you say that you have those agents, and they interact with some set of rules, and they have some types of agents in this model. So then running agent-based modeling, you actually can explore all the range of different parameters and possibilities which could happen in your system, and find the optimal set of parameters which you want to work with. So then you transfer this back to your model and go to market. But also, you don't throw away the ABM, because this is actually a very nice model. It's almost identical to your real life structure. So what you do, you can then use it for forecasting. And forecast, for instance, the viability of this model at scale, but also you can use it for daily forecast on, like, let's say you have some data from the market, then you immediately can transfer it into ABM and forecast for the future. Okay? So one interesting concept that I like from physics, so once you have agent-based modeling, so you actually can build phase diagrams. And that's a perfect thing. So for instance, you have a piece of ice and you change the temperature. So then you, like if you change the temperature in various like small variations, so actually you keep having your solid. But then you increase the temperature past the phase transition, which is 0 Celsius, and you actually go to liquid phase. And again, if you want to stay in liquid phase, you can vary the temperature quite drastically, and you still stay in liquid phase. So it's the same kind of concept works here. So you could have, for instance, some parameters in your model, and you could split the phase space of parameters into different regions. And then you could say that, for instance, you could have blockchain ecosystems where you have so-called utility tokens, and these utility tokens allow you to run transactions in between agents. And if you have a lot of transactions or a lot of agents, then you very quickly run out of these tokens. And on this phase diagram, for instance, you have number of transactions and number of participants. So if you have a fixed number of tokens, this is basically internal currency in the system. So say, so you can go to ICO, create your own currency, and then you use it for internal transactions. So actually that line will indicate when you sit in this safe phase, where actually your system functions well, there is enough tokens to facilitate all the transactions, or you actually cross this line with dynamics in time and actually go to dangerous phase, which can result that some of the transactions will just not run because there are not enough tokens in the ecosystem. So this is this concept allows, of course, to build more complex phase diagrams. So this is a very simple example, but there are quite a lot of possibilities once you have this model at hand. So how I see it now, like if you have a startup and you want to build a blockchain and you want to go to the market, so actually I see it that you first build, let's say, some viable prototype to show to investors, but then you build an ABM model and actually analyze this model at scale. And only after that you write the white paper where you actually include the results of this model and go to market and profit. So probably you want to use it. So the take-home message here is that we have rather like wide range of parameters, and we can explore them with agent-based modeling. We can leverage the immersion behavior, which apparently is there in complex systems. It's very hard to assess with traditional linear models, predictive models. And you can then, once you have your system and model running, so you can actually use it for predictive analytics. But general take-home message is you should go find some good physicists who could help you with that, because usually there are a lot of pitfalls even in modeling that these guys from physics, they know what to do. So yeah, so thank you very much. So there is a quote from Phil Anderson, that's a Nobel laureate in physics. So he quite, I don't know, like 50 years ago, he wrote a nice article which is called More is Different, where he actually outlined these complexity issues once you go to the large scale of multiple agents interacting. So thank you very much. Feel free to contact me on LinkedIn or by email. You're welcome for the questions. Yes.
Микола,
You can speak in Ukrainian, it's okay.
Коля, ты когда-нибудь рассчитывал прогноз критической линии для реальной компании, в которой есть блокчейн-культура для какого-то процесса? Если да, то какая отрасль і поделиться?
Я говорю про цю критичну діаграму. Це схемка наразі, але тобто, в мене є проєкт, він поки що під NDA, але взагалі ми будемо його паблішити спільний маркетинг робити. І ідея була в тому, що в нас є клієнт, який робить платформу і відповідно через те, що це платформа, то він дозволяє багатьом своїм клієнтам заходити в цю платформу, і вони платять якийсь вхідний внесок. І в цій платформі в них є внутрішній токен. І цей внутрішній токен використовується для того, щоб фасилітейтити якісь транзакції. Тобто ти робиш транзакцію, і ці токени, по-перше, відбуваються ці транзакції відбуваються в токенах, плюс комісія платиться системі. І токени, які йдуть в системі, вони не вертаються в циркуляцію. І було дуже важливо, щоб порахувати, чи цих токенів, які вони піднімуть за ICO, вистачить для того, щоб ця система могла працювати при якомусь... Вони очікували певний діманд з ринку, скільки в них буде клієнтів, вони очікували, яка буде кількість транзакцій, вони хотіли знати, чи вони підуть на ICO, чи вистачить їм потім грошей, цих внутрішніх токенів, щоб система працювала насправді. І це реально працює, і воно запрацювало.
Тобто ти розчитав такі?
Так. Ми порахували для різних, у нас було таких багато ліній для різних кількостей.
Оправдався, ви змогли?
Наразі вони тільки йдуть з
Обробки.
Тобто ще не почався.
Просто є прогноз, а фидбэка еще нет.
Так, фидбэка еще нет.
А еще где-то уже был расчет прогноза с фидбэком?
Чесно кажучи, для блокчейну я не бачив, щоб люди ще активно це використовували. Тобто вони почали бачити, що це дуже важливо. Так. Але взагалі кажучи, ці agent-based моделі використовуються в економіці вже років, останніх років 10 дуже активно. І в принципі воно працює дуже добре. Тобто для предіктання, наприклад, хедж-фонди його дуже часто використовують. Там не працює багато.
Опять-таки, возвращаемся к пункту 1. Нет данных, нет сведений, нет статистики, нет истории и таких вниз. Хорошо.
Тобто тут вже більше на таку інтуїцію.
Плюс-минус. Смелых просто нет. Все жалеют денег.
Насправді, якщо в тебе, наприклад, кожен клієнт приходить в систему і платить кілька мільйонів, і потім вони ці гроші зникають, я думаю, що це не весело.
Питання. Скажіть, будь ласка, що ви думаєте з приводу проблеми блокчейна 51%? Тобто те, що збільшується складність вираховування цих нод, і компанії об'єднуються далі в великі дата-центри, і далі тільки в недалекому майбутньому, скоріше за все, побачимо те, що тільки великі дата-центри вже будуть виступати учасниками нодами в цих всіх операціях. Тобто це по факту кілька великих компаній, які по факту вже можуть впливати на транзакції так, як їм завгодно, через те, що 51%.
З тих питань, але наприклад, я це не досліджував в принципі, але це можна досліджувати agent-based modeling. Я бачив статтю, де люди якраз економіку майнення біткоїну досліджують, використовуючи IBM. Вони бачать там, власне, чому у нас є цей експоненційний ріст ціни біткоїну.
Це ж взагалі не до біткоїну, це взагалі до всього блокчейну. Тобто 51% виявляється досягти не так вже і важко, як думали спочатку.
Для того треба було змоделювати і побачити.
Можно вопрос? Вот токены, о которых вы говорили, ICO, какой был алгоритм консенсуса, POW или Proof of Stake?
Нам взагалі ще ICO не провели.
А что планируется? А что планируется? Proof of Stake?
Я не займаюся інженерією самого ICO, скажімо, тому я до цього не маюся саме. Мені було цікаво, скільки є токенів в системі, і чи їх буде достатньо для того, щоб ці транзакції відбувалися. Чи система буде працювати, коли ми там...
Токены все сразу подгенерятся, или они будут увеличиваться по долям майнинга, или
Прошу?
токены будут увеличиваться?
Ні, там будуть фіксовані. Тобто той клієнт, він мав фіксоване число токенів.
Всі сразу?
Так. І потім вони просто частину вони заблокували, і частину планували поступово на рівні викидати.
А від чого залежить в основному кількість токенів? І що обмежує кількість?
Та нічого. Ти можеш, в принципі, видати скільки хочеш, просто скільки буде в тебе капіталу зайде, скільки буде backed capital. Це вже залежить від того, скільки ти підвищиш.
Мы этот актив увидим на CoinMarket, то есть он будет публичным или
Прошу?
мы этот ICO, который мы упомянули, увидим на CoinMarket?
Так.
А название вы не можете сказать?
Поки що ні. Там не бачу.
А наскільки фізика допомагає в IT? Чи то AI, чи то блокчейн, чи є якісь кореляція між знанням фізики і
Ну, наприклад, до цього проєкту мені довелося шукати, тобто мені вдалося шукати, я знав цього хлопчину. Він був в Австрії, ми разом з ним працювали. Він, наприклад, працював в групі, де вони займаються agent-based моделем для економіки Австрії. І ми працювали разом над цим проєктом. Але...
власне, є якісь принципи з фізики?
Власне, ця фазова діаграма, це здається так просто, але насправді це концепція фізична. Тобто це треба мати якусь інтуїцію вже як фізик. Знову ж таки, там багато якихось нюансів, які ти вже просто маєш набиту руку на симуляціях. Тобто в мене там 10 років досвіду, наприклад, і тобто, починаючи від симуляції якихось контурних систем, закінчуючи симуляціями процесів поширення вірусів в суспільстві. Тому тобто, воно накопичується і просто ти маєш вже ідею, як зробити так, щоб ця симуляція швидко бігала і ти міг отримати ті чи інші результати.
Тоді останнє питання повинна бути класика. Біткоін купувати чи продавати?
Я не скажу тобі. Я не купую біткоін.
Що давати такої моделі?
Окей, дуже дякую вам за вашу увагу. Я сподіваюся, англійською було для всіх окей, бо мені дуже важко українською насправді говорити. Дякую вам.